Now, we are going to take up in this video, we are going to discuss about the cantilever beam. So here, first is draw the SFD and BMD for a cantilever beam with a point load at the free end. So here, this is a cantilever beam wherein the one end of the beam is fixed and the other end is free, where the point load W is acting from the top. And then we need to find out what will be, we need to find what is the shear force and the bending moment on this particular cantilever beam. So figure shows a cantilever capital EB of length L fixed at A and carrying a point load W at its free end B. So what are the reactions at the fixed end? So because now it is an unbalanced force, so we need to have the balance in order to have it in equilibrium condition. So some of the horizontal forces should be equal to 0. As there is no horizontal load on the beam, so always RAH will be equal to 0. When you are considering the vertical load, what is that? When you have only one load is acting from the top, so in order to keep the body in equilibrium condition, you should have a load which is acting in a direction opposite to the applied load, which will be RAV, which will going to act in the upward direction, and it is a positive value. So it is plus W. Similarly, total moment sigma m, taking the moment about the point A. So that will be equal to minus W into L. So minus W into L, that is MA. Since it is negative, so it is acting in a direction opposite to that, so it will be counterclockwise direction. So clockwise direction is considered to be positive, and since it is minus W into L, so it will be counterclockwise direction. So it will be W into L is in counterclockwise. So this is the reactive moment. Now, when you are considering to the shear forces, so here, what are the shear forces you will going to get? So when you are considering this, consider a section at a distance x from the free end. When you are considering this, what is SF at this section? SF at this section is nothing but the total unbalanced vertical force. So what are all the total unbalanced vertical force we have? Fx will be equal to plus W, because when you are taking the section to the left side is positive, which is going upwards. So when the value of x will be equal to 0, so then SF at B will be equal to W plus W. As there is no load is acting between A and B, so it remains constant. So when x is equal to L also, that is SF at A, you will going to have RAV, which is also equal to plus W. So therefore, the shear force diagram here, when you are considering this AB will going to be 0. At the point B, the load acting will be plus W. So since there is no load other than W which is acting between A and B, whose length will be equal to L, it remains constant between A and B. Therefore, SF at A also will be equal to plus W. Now, when we are considering the bending moment, so what is the bending moment at the section XX? So the bending moment at the section XX is at this point, what will going to be the bending moment? So the bending moment will be equal to the load into the distance, the force into the perpendicular distance. Since the distance between this point from XX to the point B is the distance is x, so force into perpendicular distance or load into perpendicular distance, W into x. So since the beam is bending in this direction, so it will going to hogging bending moment will going to be the negative direction. So mx will be equal to minus W into x. Since the power of x is 1, so therefore from the above equation shows that the variation of bending moment from an equation is of a straight line. So that is, the variation is linear. So here, when the value of x will be equal to 0, so what happens? Substitute the value of x is equal to 0, then the bending moment at the point B will be equal to 0. When the value of x is equal to L, so substitute the value of x is equal to L. In such a case, the bending moment at the point A, the bending moment at the point A will be equal to minus W into L. So here, when you are considering that, when x is equal to 0, bending moment at the point B will be equal to minus w into 0, so it will be 0. So similarly, when the value of x is equal to L, bending moment at the point A will be equal to minus w into L. So this is how you will going to, when you plot this, the plotting you are going to get at the bending moment at the point B is 0, and because when x is equal to 0, bending moment at the point B is equal to 0. Similarly, when the value of x is equal to L, substitute the value of x is equal to L. So bending moment at the point A, which will be minus w into L. As we know that the power of x is equal to 1, therefore the variation between the point B to this point, that is the WL, will always be a linear, which is a straight line, because the power of x is equal to 1. So this is how you will be able to analyze the bending moment on a shear force diagram and the bending moment diagram on a cantilever with one end is fixed and the other end is at the free end is a W is load is acting from the upward from the downward direction. And this is how you will be able to get the solution. Thank you.